So today we're going to discuss the second section of measurements and calculations, mainly talking about significant figures. So before we do that, we need to talk about where significant figures come from, and it's mainly from measurements. And the three main measurements that we do are length, volume, and mass. So if we look at volume, volume is the amount of three-dimensional space that is occupied by a substance. And so the fundamental unit of volume is 1 meter cubed, because usually when we're measuring volume, like let's say a book or something, we take the length times the width times the height, and so that's why we have our unit cubed, because of each of those measurements. Some other units, 1 decameter cubed is equal to 1 liter, which is 1,000 centimeters cubed. And so the really important conversion here is that 1 centimeter cubed is equal to 1 milliliter. So when we're measuring solid things, we usually measure length, width, height. When we're measuring liquids, we are going to measure in, liters or some sort of liquid volume. And so that's how we relate the solid volume to the liquid volume. 1 centimeter cubed is 1 milliliter. Okay, let's look at mass. Mass is the quantity of matter present in an object. So if you can think about it like the number of particles present in something, mass and weight are different, and we'll talk about weight later, but weight is basically the force due to gravity acting on something. So mass is the number of particles or matter. The fundamental unit of mass is the kilogram, and so that's what we'll use to be doing some measurements. So now let's talk about some uncertainty. There are 2 parts to every measurement. The first is called the certain number. This is the number that everyone would agree on. So for example, if we are measuring the length of this arrow on a ruler, I lined up the end at the 0. Now if we're doing it in inches, the end of the arrow falls somewhere between 2.5 and 2.6. So we would all agree that it's at least 2 inches and a little longer than 2.5 inches long. And so those two, the 2.5, that would be our certain number. The uncertain number is the estimated part, and it can vary. And so let's say I look at this and I say that it is just a hair on the inside of 2.6, so I'm going to call that 2.58. Well, you may measure it and say, no, it's not 2.58, it's 2.59. And someone else may measure it and say, nope, it's 2.57. Okay, well, that last digit, the 7, the 8, or the 9, those are what are called our uncertain numbers. That's estimated. So everyone would agree that it's at least 2.5 inches long. But then that last part is what's going to be estimated, and that can vary. We always, when we're taking a measurement, record all certain numbers and then the first uncertain number. And so we're always going to estimate one place past what we can read on our measurement device. And that's called the degree of uncertainty. And it depends on our measurement device. So here, if I look at my inches, because it has measurements in the tenths place, I want to record one place past that, and so all of my measurements on this ruler should be to the hundredths place. So you're always going to record one place past what you can read. This would be the same on a thermometer or any other sort of measurement device. Okay, so this is where significant figures come in. Significant figures include all the certain numbers plus that first uncertain number, and so when we read significant figures, that gives us an idea of the uncertainty of the measurement device. So if we read on a ruler, or this is a scale, and we get 1.86 plus or minus 0.01 kilograms, so that hundredths place was where the degree of uncertainty was, then that means that our measurements can range from 1.85 to 1.87. And so that's the degree of our uncertainty. Okay, so now let's look at how to, number 1, count significant figures and then use them in calculations. Okay, so the purpose of significant figures is to determine uncertainty. Uncertainty can multiply on itself as we put this into calculations, and so we have these certain rules for determining significant figures. Okay, there are 3 parts that we're going to look at. The first is counting significant figures. We're going to look at non-zero integers, 3 types of zeros, and then what happens when we have exact numbers. Then we're going to talk about how to round off numbers to specific significant figures, and then we're going to look at using significant figures in multiplication and division, and then also in addition and subtraction. Okay, non-zero integers are basically any number that's not 0, and these will always count as significant figures. So if we have the number 1,457, because those are all non-zero integers, they would all count. And so we have 4 significant figures, because they're all significant. Okay, we have 3 different types of zeros. So let's look at the first type, which are leading zeros. If you are leading, you are in the front. And so leading zeros are zeros that precede or come before all non-zero digits. These would never, ever, ever count as significant figures. These zeros are indicating the position of the decimal point, but they are not indicating significance. So if we have the number 0.0025, these 3 zeros are what we would consider leading zeros because they are all in front of or preceding non-zero digits. And so because they don't count, the only significant figures in this number are the 2 and the 5, and so that gives us 2 significant figures. Okay, the second type of zero are what's called captive zeros. If you are captive, then you're in the middle. You're stuck. You're taken captive. Okay, and so these are zeros that fall between non-zero digits. These always count as significant figures. If they're in between 2 digits that always count, then they must have to count too. So if we look at 1.008, these zeros we would call captive zeros because they're in the middle of a 1 and an 8, and 1 and 8 are non-zero digits. So they would always count, and so we should have 4 significant figures in this example. So all of these would count as being significant. Okay, our third type of zero are trailing zeros. If you're trailing, you're at the end. And so these are zeros that are at the end of a number. Okay, these will only count in certain situations. If there is a decimal point, then these zeros would count as being significant. If there's no decimal point in the number, they do not count. Okay, so if we look at something like 100, these are trailing zeros. They're at the end, the right end of a number, but there is no decimal point. And so they would not count. Only this one would count, and so we would have 1 significant figure. So remember, this is indicating the measurement device and how significant the numbers are in the measurement device. So this is where we have differences. Let's say we had 100 again, but now we have this decimal point here. So now we're indicating something about the measurement device. Because there is a decimal point, these zeros do count, and so we have 3 significant figures in this example. Okay, what if we had 100.0? Now we have 3 trailing zeros. We have 2 that are before the decimal point and 1 that is after, but they are all after a non-zero integer, so they all count as trailing zeros. Because there is a decimal point in the number, all 3 of them count, and so we would have 4 significant figures. So even though in all 3 examples we have the same value or quantity, we have varying degrees of significance based on where that decimal point is, and that's based on our measurement device. Okay, and so this does give a lot of information about what device was used to measure and how significant that is. Okay, our last category for counting significant figures are exact numbers. Now, these are not used in determining significance at all, so we would say 0 significant figures or does not apply. And these are either counting numbers or definitions, which we're going to call conversion factors, which we will talk about in a little bit. So, for example, 1 inch is equal to 2.54 centimeters. This is a definition. It's just defining inches versus centimeters and the relationship between the two. And so we would not use those numbers at all in determining significance. The other one is counting. If I count some apples or I count some students or cars or whatever, that's just determining a quantity, and that is not used in determining significance. So we would say 0 or none at all. So 0 significant figures for both of those. Okay, let's look at a few examples. Okay, so we have 0.00100. Well, first of all, these 3 zeros here are leading zeros, and so they do not count. Here we have a non-zero integer, so that counts. Here we have trailing zeros, which only count if there is a decimal point. And because I see a decimal point, I know that these will count, and so I should have 3 significant figures. Okay, 2.08 0 times 10 to the second. Now this one is in scientific notation, but that's okay. We're still just going to look at the number, not the times 10 to the power. Here I have a non-zero digit, so I know that counts. Here this 0 is a captive 0, so I know that it counts. My 8 counts because it's a non-zero integer. Now I have 2 trailing zeros. They only count if there is a decimal. There is, and so they also count. So in this case, all the numbers count, and so that gives me 5 significant figures. Okay, here I have 480 cars. Now because this is a counting number, I would say that none of them count, and so that would give me 0 significant figures. And the last one, 150 grams, I know the 1 counts, it's a non-zero integer. 5 counts, it's a non-zero integer. And then the 0, this is a trailing 0. It will only count if there's a decimal. I don't see one, so it does not count. So that gives me 2 significant figures. Okay, try this last one on your own, and then we'll look over the answer. Okay, so the second part is what to do when we want to round off some sort of number or calculation to a certain number of significant figures. If the number, so if we look at how many we want to round to, and we look at the number right after where we want to round, if that number is less than 5, then that preceding digit that we're looking at of importance, that stays the same. So, for example, let's say we want to round the number 1.33 to 2 significant figures. I look at the number after, it's a 3, it happens to be less than 5, and so my preceding digit stays the same, and so that means that when I round, my number is 1.3. If the number after the digit of interest is greater than or equal to 5, then that preceding digit is going to increase by 1. And so if we look at the number 1.36 and we run around that to 2 significant figures, now when I look over at the number after my digit of interest, it's a 6. That's greater than 5, so I'm going to round up. So that makes my rounded number 1.4. I only want to use the first number to the right of the last significant figure. I don't care about any of the numbers after that. And so, for example, if I'm rounding 4.348 to 2 significant figures, I'm going to look at just the 4. I don't care about anything that comes after that. And so this would round to 4.3, not 4.35 to 4.4 because of that 8. We're only going to look at the digit right after and then ignore everything else. If you're going to do more than one calculation, which will happen, don't round your significant figures after each calculation. Round at the very end. So do all of your entire problem, get your final answer, and then look back into the problem and base your significant figures off what's in the problem. Okay, the last part that we want to look at is how to determine significant figures in those calculations. If we are multiplying and dividing, we are going to count the number of significant figures. So the number of significant figures in the answer is equal to the smallest number of significant figures in our measurement. And so if we look at this problem, we have 4.56 times 1.4. This number has 3 significant figures in it. This number has 2, and so if I'm basing it on the smallest, I know I want my answer to have 2 significant figures. And so that would take me to the 3. I look at the number right after the 3, it's an 8, and so I know that that is going to round my number up to 6.4. Let's look at a division problem. Okay, we have 8.314. That's 4 significant figures. 298 is 3 significant figures. So if I just get your answer, and now let's round. So we know our smallest is 3, so we want 3 significant figures. These don't count because they are leading zeros. So 1, 2, 3. The number after is a 0. That's not going to change anything. So my number ends up being 0.0279, or I could put it into scientific notation, which makes it a little easier to see significant figures, 2.79 times 10 to the negative 2. Addition and subtraction have their own set of rules. Here, instead of counting significant figures, we're going to count decimal places. And so the number of significant figures is determined by the smallest number of decimal places. And in order to determine this, we need to line up our decimal points. So let's look at this one. First thing I want to do is line up my decimal points. So I have 12.11. 18.0, and 1.013. Okay, so if I line them up, I'm looking for the place that they all have in common that is the smallest. And so I'm going to start and move this direction, and it looks to me like the 10th place is the place where they all have a significant digit in common. So if I get my number and I want to round it to the 10th place, the 2 isn't going to do anything to the 1, so my answer should just be 31.1. Let's look at a subtraction. So again, same thing. I want to line up my decimal places. 6875, 0.1. Okay, well, if I start from this direction, the place they have in common is again the 10th place. Just do your math and then look at rounding. 10th place, the 8 is going to round my 5 up, so my answer should be 0.6. Okay. We already talked a little bit about scientific notation, but it's nice with significant figures because it's a lot easier to see the number of significant figures. It takes out some of those extra zeros that might be confusing. And so you also need fewer zeros, which makes things a little nicer. So if we had this number, remember all of these are leading zeros, so they wouldn't count. This is a non-zero integer, it counts. This is a trailing zero that counts only because there is a decimal point, and so we have two significant figures. Well, an easier way to write this would be 6.0 times 10 to the negative 5th. Now we're taking out all of those leading zeros that don't count as significant figures, and it's making the number much easier to look at as far as significant figures are concerned. Okay, so try these examples on your own, and then we will go over them to see how you did. Have a good day.